Hello everyone, today I am explaining the topic motion in a plane, motion on smooth plane curves. Let us suppose the position of a particle on the curve. This is the curve at any time t, bp x, the coordinate of p be x comma y with the arc length s measured from a fixed point p1. Let v be the velocity at P and x comma y or the components of the force acting on the particle along coordinate axis A. Normal reaction R acts at P on the particle because the curve is smooth. On resolving the forces along the tangent at P, the motion is given by mv dv by ds is equals to x cos phi plus y sin phi. This is the equation first. But cos psi is equals to dx upon ds. Sin psi is equals to dy by ds. In this figure, we concluded that this. Then we have mv dv by ds is equals to x dx upon ds plus y dy by ds. Integrating with respect to s, we get integrating the equation, we get that x dx plus y dy plus c1. Let us take x dx plus y dy is equals to phi x comma y, and we let the x is equals to del phi by del x and y is equals to del phi by del y. Then we have half mv square, and integrating this in equation second, here phi x comma y is known as work function and half mv square gives the kinetic energy of the particle at the point whose coordinate is x comma y. Next, we have explained the motion in the plane. Speed. The speed of a moving particle is the rate at which the particle describes the path, straight line or curve. The average speed of the particle is defined is equals to average speed is equals to total distance traveled upon total time taken. Let the particle moving on a curve having the position p and q at any time t and del t, such that AP is equals to S, AQ is equals to S plus del S as shown in figure. Then instantaneous speed of the particle is equals to limit del T tending to 0, del S upon del T is equals to ds upon dt, which is generally said to be the speed of the particle. Velocity. Let a particle start the motion along OA. It is at P and Q at any time t and t plus del t, such that OP is equals to x and OQ is equals to x plus del x. Velocity of the particle is equals to limit del t is tending to 0. Del x upon del t is equals to dx upon dt is equals to x dot. Acceleration. The rate of change of velocity with respect to time is defined as acceleration of the particle. Let the particle be at P and Q at any time t and t plus del t having the velocity v and v plus del v. Then acceleration is equals to limit del t tending to t, del t tending to 0, del v by del t is equals to dv by dt. Here d by dt is equals to dx by dt. We have to write velocity as dx by dt, so d square x is equals to dt square x v, and also we written as x double dot or is v dv by dx. Equation of motion. For a particle of mass m having velocity v, the momentum p is given as p is equals to mv. By Newton's law of motion, we have d by dt is directly proportional to f and is equals to dp by dt is equals to kf, or d by dt is d by dt into mv is equals to kf, f is equals to mf. Next, we proceeding components of velocity and acceleration. Let the particle moves along a curve r is equals to f theta at any time t. It is at P and at the time t plus del t it has the position q as shown in figure. Here OX is the initial line, O is the pole, OP is equals to r which is radius vector, and angle POX is equals to theta, which is vertical angle. The velocity or component of velocity along OP is radial velocity and acceleration known as radial acceleration. The velocity or component of velocity and acceleration perpendicular to OP is known as transverse velocity or transverse acceleration. Radial and transverse velocities. Distance covered along radius is equals to PL. Velocity is equals to limit delta t tending to 0. PL is upon del T. R plus del R cos del theta minus R upon del T is equals to limit del T tending to 0 is equals to dr by dt. Radial velocity is equals to dr by dt is equals to r dot is equals to u. Transfer velocity is equals to limit del T tending to 0 ql upon del T. Where transverse velocity is equals to r del t d theta by dt is equals to v, which is equals to transverse velocity. Next proceeding, radial and transverse acceleration. Radial acceleration is equals to limit del t tending to 0 change in velocity in time del t upon del t, which is r double dot minus r theta square. Transverse acceleration is equals to limit del t tending to 0, which is equals to 2r theta dot plus theta double dot. Center orbit by Kepler's law. Kepler's law of planetary motion. Kepler's first law: each planet describes an ellipse having the sum in one of its foci. Second, the radius vector drawn from the sun to the planet describes equal areas in equal interval of time. The square of the periodic time of the various planets are proportional to the cube of the major axis of the orbit. Hence, we completed the